Hello there. Today we'll be doing the problem first missing positive. Given a list of integers, nums, find the missing positive integer. In other words, find the lowest positive integer that does not exist in the list. The list can contain duplicates and negative numbers as well. So the first thing we can do is that we know that we should start at 1. And we're going to check this numbers array for that 1, and then for the 2, and then for the 3, and then for the 4. Until we don't find something, then that's our missing number. So let's remove all the negatives. Well, we don't need to actually remove anything because we're going to use a set. Actually, we use a set to remove the duplicates and make it easy for us to find the first number. So while start in nums start plus equals 1. So what happens with that is that while 1 is in there, okay, 2 is in there, 3 is in there, everything we want to know is still in the set. So once it's not in the set, right, just return start plus 1. Wait, actually, no, return to start. Actually, return to start. Run. Resubmit. Uh-oh. What happened here? Time limit exceeded. Oh, I see. Forgot to set the nums equal to the set, so it's a lot easier to find our numbers. Okay, that's the simple way to do it. This is an O of n time and O of n space because of the creation of the set. And looking up every single number inside the set from 1 through the maximum limit of the nums. So there is a better way to solve this, which requires O over 1 space, and we'll be reusing the array as our placeholders for the items that exist or does not exist. For all we know, there can be only a maximum number of positive integers in this list, and that is all the way up until nums, like the length of nums, right? So once we hit the maximum length of nums, those are all the positive integers. And so we can use the entire length of our array to store whether or not it exists. 0 would be represent 1, and 1 represent 2, and so on and so forth until reach the length of n, the index length n, length of numbers minus 1, which is the end of our items. And if it is more than our items, then we just return n because that's over our limit. Okay. We can do this in 2 ways. We can do a very fancy math approach where we use the n as our placeholder and add that to our current number so that when we take the mod of the current by n, we can find the previous index at that particular number. Or we could because we're writing in Python, we could put strings in our array and mix it with our integers and get our original number by converting it back into an int and checking it. Well, those are 2 methods. I'm going to start with the easier method to explain, which is the string method. Then I will explain the math method. All right, so here we go. First of all, we're just going to for I and num in enumerated of nums. So n is equal to the int of n. if 0 is less than n and greater, less than or equal to the length of nums, then we want to, you know, increment this particular location, n minus 1, equal to string nums of n minus 1 to signify that, oh, we have seen this number at this particular index. Let me change it into a string of this particular number. And the next time we see the same number, we can also take it out and turn it into int and redo the same thing for the next placement of the integer. So for I and n in enumerate at nums, if n is equal to int, return int I plus 1. Because we're using the 0 index, we're not modifying the index, the nums at all. We have to use the 1 plus, because 0 is 1 and 1 is 2, and so on and so forth. Unless we append an additional item onto array, I don't think that's breaking the rules, but currently we're just doing it this way. Otherwise, we have hit our limits, and we just need to extend it one past our current array. So run, submit, and it's a very slow, apparently, because we replaced, we took our sweet time running through 2 loops, and doing a lot of things in these loops. That is why it will take a little bit longer than the set. So now we're gonna do the math method, and we're gonna append the 0 to improve the text, the implementation of this this code. So lang nums. So now that is the last number of our possible positive numbers, and if we make it all the way to the end, we can return n. Otherwise, let's take a look at what's gonna happen in the middle. So first things first, we want to clean up our numbers when we're doing math, because we don't want to mess around with negative numbers or duplicates or anything. We have enough numbers to worry about already. So if we're dealing with math, we have to clean up our numbers. So we're going to remove all our numbers that are greater than equal to n, because n is our maximum possible number. And we want to remove anything that's less than 0, because that will just, there are no negative indexes, right? So we get rid of those. So for I in range of n, now we can popularize our array with our plus equals n. The reason why we do the plus equals n, because every time we find that particular location, we don't want to mess up the original number. So that's why we have the modulus and the plus equals n. So now for I in range, I and n, we're going to start from 1 and go to the end. The reason being we can do that is because we added that 0. So if nums of I divided by n is equal to 0, then we have found our location and return I. The reason why we can, anything divided by n, which is a 0 divided by n, would be equal to 0. Anything else, like a 1 all the way till n minus 1, which is going to happen here, will not result in a 0. If it does result in a 0, that means that particular point was never adjusted by n. We never got a plus equals n for that particular spot. right? So, one more thing. Okay. Anyways, with that, we can return n, and we should have the right answer. Um, there is one thing that I am personally thinking about that is questionable. Questionable bit is that what happens actually to the parts? I mean, this is if it's greater than n. What happens to the items that are never seen? Like, and how is that bottom out divided by n? Like 33 or 24. We never set it to 0. We never set that spot to 0. That num's location in the array, say the 24th spot, let's say we never got to it. Like, we never modified it. So what happened to it? Like, how come this works? Like, that doesn't make much sense to me. Because we never set it to 0. Yeah, that does not make sense to me. Yeah, so anyways, if you have any questions, please comment below. If you enjoyed the video, like and subscribe. And if you want more videos, check out the link in the description below. And I hope to see you guys in the next one. And if you like to stay, I'm going to now just trying to muck around and find out why exactly would something that has never been modified would retain would become a 0 when floored to n. Nums I modulus n. Huh. Well, all of those spots have been set to 0 actually. I see. So this sets all of those numbers that are greater than the current number to 0. And when we read that spot, it's going to give us a 0. And numbers that are inside our value system will be changed here. And I think that's how it works. Okay, so that's all, and I'll see you guys in the next one.